Yeah.
How about I do this?
We're on. We're live.
I was going to say. All right. Very good.
We're good.
Let's have some fun. Yep,
Good to
we're
go?
on. Yep.
All right. I am Adam Mufich with National Comfort Institute, and I am here with Dominick Guarino and Steve Rogers and Christopher Hughes from the Energy Conservatory. And we want to talk a little bit about the air upgrade process and how we kind of changed the path of testing, right? I wanted to turn this over to Dom, and can you explain the history of the air upgrade and how it came to be?
Sure. So NCI has been teaching air balancing, air diagnostics, that sort of thing for about 30 plus years. And just about 5-6 years ago, we kind of looked at, what can you do to a system, almost like, I don't want to say the bare minimum, but what key things can you do to make sure that the equipment is actually operating in the range it should be operating? Like, it can breathe, static pressures, get the right airflow and that sort of thing. And then checking the charge if it makes sense. If you got your deltas and everything, you're good to go. But so typically that air upgrade were some surgical things that you do. For example, change the return drop, because a lot of those are just designed poorly. They're very restrictive and so forth. And then some key other things to the system that the equipment is attached to. So that was the concept of the air upgrade, and doing it as simple as possible, and doing it, and most important, doing it through testing and actually seeing what you have.
Right.
I want to take a second to make a comment here. I am what I would call a very traditional technician. My dad was an HVAC technician. Then I became an HVAC technician. I went to traditional HVAC trade school, got trained up, and then went into the field. What I remember is not getting any airflow training in trade school. It just assumed that you would pick that up when you got into the field. Electrical was very, very important. We built sheet metal in the back in the shop. We worked on different units. Superheat, subcool was all taught. Airflow was not taught to me when I was in trade school. So I go to the field and I made lots of mistakes. I had lots of problems, lots of water carryover problems that I fought. And for years and years and years, I did the best thing I could do, and I've had equipment, distributor superstars who would come out there with me. And this is the crazy part. I would have industry professionals with me go to the job. This job has probably an undersized return. We all didn't know it, right? And we're in a commercial space. Engineer maybe designed it, don't know. But maybe the filter went from like a MERV 6 fiberglass filter, and we were putting in a nicer filter, MERV 8 or something, so it's more restrictive. We're getting water carryover issues. We've upgraded the equipment. And the rep of the equipment's coming out there with plexiglass, putting on there, and we're watching water just trickle off the blower, and we're like, we should slow down the blower, but we don't really know why we're doing it. We're just trying to make the water stop. So we're just, and we think we're some of the best in the industry at this point.
Yeah. It's, go ahead.
I'm just, to finish that off, it's like, wow, and I went the proper route, and how many more people went the proper route and don't have the airflow training? And that's the big problem that we're trying to identify and fix.
And I'm hearing that HVAC is kind of like real estate. We all know what the three most important factors are in real estate. And I think three most common problems in HVAC are airflow, airflow, airflow.
Absolutely.
Yeah. Yeah, I think I remember when I first learned, I actually told this story at the symposium a few days ago, but like when I first learned static pressure, you learn how to measure static pressure, but you don't really know, and you don't learn what it means and what the individual measurements mean, right? So what is good, what is bad, and why is it bad?
Sure.
So,
but one example is, if you're looking at total external static, you might actually have a problem on the supply side and the return side, but the problems balance each other out, and all you're looking at, is total external static. You might miss what's going on with the system. So you learn the basics, but then you start to become a practitioner, if you will, in that. And the more you learn, the more it's like, wow, okay, didn't know it could do that. And like, for example, on a return, we would put a static pressure probe on a return drop, and there would be positive pressure in the elbow. There's so much turbulence. So you only learn that by kind of getting out there and testing.
I heard David Richardson on a podcast talk about you start with static pressure, that's where you start. Mm-hmm. But if you only measure static pressure, it can fool you.
Yeah, exactly.
So you got to start learning airflow measurements as well as static pressure.
So why don't we get into the air upgrade process?
Sure.
Yeah.
Go ahead, Adam.
So everything was kind of done by hand, manually before, right? Like we were taking our measurements, and we had something called static pressure budgets. Mm-hmm. National Comfort Institute developed basically like a little chart. It was like a cheat sheet where you could fill out by hand with a pencil or pen what your measurements are, and it would tell you if you're in a good range or not. We're all moving over to like a smart-based app type deal where we have smart tools, and we're trying to get more precise with our measurements in that. So National Comfort Institute partnered with the Energy Conservatory to develop an app.
Right. We combine training and technology. So what I was talking about earlier with the problem that we were facing, not knowing the airflow coming out of, say, trade school, or no senior technician who finally picked it up is teaching the younger crowd, we could take the training that NCI is teaching, and there's some parts that where training's hard, right? Training's hard. You can't ever let technology take over training. I'm established that now. But what we can do is make the training be more impactful if we can make the small stuff go away. And what I mean by that is I've talked to many technicians who are taking static pressure, and some of them don't get the proper training, and they're calling TESP is the return duct and the supply duct when it's a furnace and coil. And I'm like, well, no, that probe has to be after the furnace but before the coil. That's what TESP is on that system. And we can solve that with a picture. And if you give us a couple answers, well, then we lay out a picture to show you where the probes go. Now, moving forward, an app's not going to tell you how to go fix it. That's where training tells you how to go fix it, which is like an NCI duct system optimization class. If you have high pressure in the supply, well, where at in the supply? The app's not going to do that for you.
Quick correction. Airflow testing and diagnostics would be like the starting point where we're analyzing those pressures.
Right. And so I don't want to jump too far, but I feel at this point we kind of got to go a little further.
Yeah.
And what I mean is, if you hear this and you want to get started and you like the idea of a picture to follow, there's apps for this. And there's another company that should be sitting on the stage right now, which is MeasureQuick. It's really 3 companies that brought this air upgrade process together. Mm-hmm. And we have the workflows for you. Now, here's the really cool part. You start right now for free. The app is free. You can do the processes with any manometer that you have right now for free. And then as you learn more about airflow and static pressure, you will have to acquire tools to get more purity and measurement, and then you'll have more capabilities. So let's say you're a service technician and you're just solving some airflow problems. You could get started with a manometer. You can take it further if you have a Trueflow and a manometer. But we didn't want you to get started with a Trueflow right out the gate if you don't have proper training. It's a stepping stone process.
Can we talk a little bit about, let's talk about the most basic workflow in the Trueflow app.
So there's 3 workflows, and if you open the Trueflow app, so the app you want to go looking for is called Trueflow HVAC Airflow. And in that app on the main screen, you'll find that there's 3 NCI workflows. There's one that just does a static pressure screening, so you're not really trying to estimate airflow. There's one that does the AirMax using the fan table. So there you're going to estimate airflow. And then the third one is AirMax with the Trueflow grid, so you're actually measuring the airflow and the static pressure mapping.
Okay. Do you want to dive into the static pressure screening a little bit?
I can. So what is static pressure screening, right? And so let's take that furnace and coil, for example. In that situation, you're taking 4 pressure measurements. You're going to take the first one before the filter. So what you're doing when you take that pressure measurement is you're measuring the resistance that the return ductwork is creating against that blower. That's the idea of that pressure measurement. When you take the second pressure measurement, you're going to have a picture to follow the whole time. When you take the second one immediately after the filter, well, now you're doing two things. One, you're going to now have the other side of the filter, so you note filter pressure drop, and you're also going to see the return side of TESP, which is all of that combined. Then the third pressure measurement is going to be after the furnace, before the coil, and that one's going to give you all of the resistance on the supply side, which makes up the other side of TESP. Okay, and then when you make your fourth pressure measurement in the supply duct after the coil, you're accomplishing two things again. Now you know the DP across the coil, and now you also know the supply resistance. Now, what we've done is we've taken all of those factors and we've put them in individual colored dials. And those dials tell you what's good and what's bad. Now, that is the basic workflow that gets you started, but there's some caveats there. Okay, that's free. Free always comes with somewhat of a flaw or an Achilles heel. What's the Achilles heel in this case? A dirty system. Those pressures don't necessarily matter as much if the system's dirty, which means sometimes you may go, oof, like these are good numbers, but maybe they're only good numbers because you're not moving the airflow that you're wanting to move. And so you're like, oh man, it's kind of a false positive.
And I wanted to mention, because you were walking us through like the furnace workflow, but there are, you could pressure profile an air handler as well too, right?
You could. So that's the importance, I think, of the pictures, is if you have an air handler, everything's built into the box that is shipped, the as-shipped box. So the coil's made internal, so you're only taking, let's just say you have a filter and an air handler, no coil. Well, now you're only taking 3 pressure measurements. You don't need a pressure measurement between a furnace and a coil because the coil's in the box as shipped. So TESP is everything outside of that box. So you're only taking 3, you'll get 1 less dial. So that's kind of like these things that I'm explaining, all of these are pictured so you can follow the workflow.
Yeah, so that's the two problems I think that the technology helps to solve. NCI has been teaching a great process for many years, and it's worked very, very well, but there are a couple places where people got tripped up. Chris mentioned, where do I put the holes in the system? Or where do I add the static pressure ports? And then the second question, or the second thing that can trip people up is doing the math, making sure that you got 4 different pressures that you measured. Which ones do I subtract, and what about the sign? And that's maybe different than I learned in algebra class. Right. And so by using an app and just entering the numbers, or by mapping the numbers direct from the manometer, all that goes away. It makes it just that much easier. Just use the technology. Picture tells you where to put all of the pressure ports, and the app takes care of all the math. And then it also helps you interpret. Like Chris mentioned, there's a dial on each measurement. Red, yellow, green, just like a stoplight. If you're in the green zone, awesome. Yellow, caution. And if you're in the red, you better take some action.
It should be worth mentioning dials that are influenced by the National Comfort Institute's training. So the dials' colors are being set by these guys.
Yeah.
I want to touch on reporting a little bit. So is there something that the app generates? Can we, with all 3 airflows, is there anything that we can present to a homeowner or a customer and say, hey, this is what we have. This is a third-party measurement, right? How do we present this information?
So we, the best way I can say this without sounding greedy. Okay, we're in business to make money. There, we've said it, right? We need to make a living, or else we can't come here and we can't educate and provide training and things like that. So selfishly, there needs to be some level of holdback. And so you don't get a PDF report out of the app unless you've done a Trueflow test. Right. So that's one of the things we've kind of held back.
But the thing is, the trade-off to that, it's a Trueflow app that's providing these tests, and you could use a YouTube manometer, you could use a MagnaHelix. You don't have to use anything digital or a smart tool to use the two first, the static pressure screening or the fan table workflow.
Yeah. Another way to look at it is if we're going to provide a nice PDF report that has measurements, then we want to verify the tools that it was taken with, just like you mentioned, Adam.
Yeah.
And so with the other ones, the other workflows, if you're not using a tool that we know what it is, then we're still going to give you a results screen. It's going to give you that information. It's going to give you some interpretation of what you've just measured. And you can take that screen capture. That's still suitable to show to a homeowner, to take a screen capture of it, send that to the homeowner, just kind of like the full report that is, PDF that you can mail.
Yeah.
That's where we want to make sure we're taking those measurements with verified instruments.
It's interesting when going back maybe a few decades. So we basically used magnehelic gauges before they were all this digital came out and communicating and smart tools and so forth. And part of all of this is, okay, we're a bunch of geeks, right? This is what we do. But it's the homeowner, the consumer. One of the advantages of the magnehelic was they could watch the needle go up, and it's like, well, it's supposed to be here, and now it's here. And for a while there, we started using digital gauges in our training, but that took away that visual. So I think one of the things that the Trueflow does, or the software, is it's bringing back the gauge that a consumer can immediately identify with, like good, bad, that kind of thing.
Yep.
So that's something else that I think makes it very valuable.
Yeah.
I would also say when we did this, there's two ways to go about it. You can make technology more confusing, and we did a class about that on inverters,
Yeah.
so I think we made our point there. But if I looked at the diagnostic codes that I could offer with static pressure only, let's say it's an existing system and it's dirty, and me and Steve looked at all these diagnostics that are built into the app when you have a purity flow measurement from the grid, and we said, okay, what if we didn't take a purity flow measurement from the grid and we're assuming the flow based on pressures? How many of these diagnostics are 100% confirmed to be the thing? And when we stripped it and we didn't have flow and static, it was going to be a whole lot of this is a maybe, and this is a maybe, and this is a maybe, and it was going to get to the point where the diagnostics were forever long, and there was a whole lot of, well, this could be 50% true, and it was either go that route and have people reading a laundry list of things they could go check, or they could just step up to a purity flow measurement and get diagnostics. And we were like, okay, as a manufacturer and from the field experience, and we were like, what's the best route? And that's why we made the choice. It was like, okay, you're going to get diagnostics when you give us more pure information. And so that's the choice we made.
Let me give a concrete example of what Chris just explained. A lot of times you take a static pressure measurement, you're doing it correctly, you verify that you got a half inch of static, and that's good on almost any system. You've also verified that you're on the speed tap that you want, confirmed that should be the airflow that you need. And that, if you've only measured static pressure, that all checks out, that all looks good. But if you've got a furnace that's a 90 plus and the secondary heat exchanger is all clogged up, you could be getting a good static pressure on the speed tap that you want, and you're still only delivering half the flow that you think you are. The same thing can happen on a fan coil if the evaporator coil is all super dirty. So there are cases when this is, where I heard David talking about, it can trick you. And so just like Chris said, we looked through all the diagnostics and what can we do if we only know pressure? And the answer is not a lot. So the pressure screening, I think, is useful if you've just installed a new system and you've selected the speed tap that you want, you confirmed that. You could just measure the static pressure and verify that it's in the range that you want, and you have pretty good confidence that you've got the airflow that you need. So static pressure screening, I think that's a good way to do it on commissioning a new system, as long as you've looked up the airflow in the fan chart and set it to what you need.
Right.
Yeah.
Well, common, I don't know if it's a misconception about static pressure, but it's counterintuitive. Because you think that, okay, if you have a major blockage in a system, that your pressure is going to go up. But in reality, your fan can't move the air, especially like a PSC motor, can't move the air, and your pressure actually goes down. So it's kind of counterintuitive.
Yeah.
So unless you're looking at both, you can be easily tricked into
Yeah.
thinking it's something, but it's actually something else.
That was, and I think a lot of people have that aha moment when you go to make a repair on a system and you have, you might have high static pressure and low flow.
Right.
And then you solve one of the issues, like a pressure drop issue, and then your flow goes up, but your static pressure also goes up.
Right.
And you're like, what is going on here, right? We talked about the static pressure screening. We talked about the fan table. So, guys are using their MagnaHelic or their, inexpensive digital manometer, and then they finally take the jump to the Trueflow, and they say, hey, I want to use the Trueflow. You mentioned diagnostics. What type of diagnostics are they going to get, and how would they expect to see it presented to them?
I'll take that one.
Okay.
So, for example, we're measuring on a furnace and evaporator coil with a filter slot. We're measuring the 4 components that all 4 add up to your static pressure. And if your static pressure is high, we're going to break that down and tell you which area has the restriction, or where's the bottleneck in your system. And for example, if we measure that it's the drop across your filter, then we're going to tell you, well, there's 3 reasons why you have a restrictive filter. Number 1, it's really dirty. Number 2, it's too small. Or number 3, it's too restrictive a filter for that size. And so we'll give you those 3 diagnostic bullet points if you look at the details, and that's where you start looking. And we do similar things if the restrictions in the supply ducts, if the restrictions in the return, or if the restriction is in the evaporator coil.
Nice.
So, yeah, and where would you find it? If those are listening to this, here's what I would recommend. If you want to see what it looks like, and please do this for me, because I get a lot of tech support calls, and people have never opened the app, but they're asking questions, and I'm like, well, have you looked at the app? They're like, no, I haven't started yet. And I'm like, are you scared? Like, go for it. Trust me. But you can download the app. That's free. And there is a section in the settings that says demo mode. If you toggle on demo mode, it lets you connect to the fake hardware and run any workflow out for free. It's just like a simulator. And you get to see what everything looks like. And if you do that, I guarantee you a lot less questions.
So there's a middle ground too. We talked about using your own manometer or the TEC manometer with the Trueflow grid. But if you only get the TEC manometer and not the grid, which is quite a bit cheaper, you can do those pressure diagnostics automatically, where it's going to Bluetooth connect and it's going to automatically record the pressure each time you put the probe into a different spot.
Right.
So my question to you, Adam, we have a second workflow. Why don't you, I would let you take a run at this. Second workflow is static pressure profiling the system and using the OEM flow chart. You want to tell them about that one?
Yeah, the fan table. So same type of deal. We're going to be looking at duct pressures. We're looking at pressure drops, right? So we're measuring pressure before filter, after filter, before coil, and after coil, if it's a gas furnace. You look at what the total external static is of the system, and then you actually have to reference the fan table of the equipment. We capture the fan table of the equipment, and we're using those pressure measurements to plot the fan airflow. It's not a measured airflow. It is an estimated or calculated airflow. So that's the one caveat with that, right?
The nice thing about it is it tells you what your TESP is, so it tells you which column should I be looking in.
Yep.
So you don't have to do the math. It's you just put the probe in the 3 or 4 locations that it tells you to, and then it tells you which one is the TESP, so you make sure you're using the right column in that.
It's a guided workflow, so it's telling you what to do, and that's another thing that confuses a lot of guys, especially early on when you're first learning how to measure static pressure and you're figuring out what total external static pressure is. Absolute values. We're not paying attention to the plus and minus in the pressure measurements, right? And the app kind of does that for us.
Yep.
Just to add on top of that is what Adam said is you can get the flow measurement from the fan tables, but you could also use the NCI fan tables. You want to tell them about that?
Yeah. Actually, there's generic fan tables that we have developed, and Dom, you probably have more history on where they came from and who actually
Sure.
developed them.
Well, so Rob Falk, who's one of the founders of NCI, took it on as a project to have, and actually it was John Purrier, I believe, to collect fan data from literally hundreds and hundreds of units. And then so we were able to come up with sort of an average. So it's not right on, but like here's what a typical unit might have in terms of external static pressure ratings, and the calculated fan airflow, if you will, from that table. So that's how we developed the table. And the idea wasn't, we weren't shooting for perfection. It's more of a diagnostic tool for a service tech. So is it, it's supposed to be 0.2. So is it 0.22 or 0.19? You're getting into that gray area, and the reason was it was for the diagnostic, not to dial in the exact pressure.
And
I
it's
think that's
the whole thing is it's not one table. There's multiple tables, and
Right.
we're looking at different fan motor types.
Correct.
And we're looking at static pressure, right?
Mm-hmm.
And the thing is, we always talk about at NCI, like if you're going to use the generic fan tables, if you have the OEM available, use the OEM. But this is something like if you cannot find it, if this is an old piece of equipment, if you don't have
Or
the
you-
model number,
Can't get a model number. It's gone.
this will get you
have
close.
something.
No
you know
nameplate.
tonnage, and you're reaching right, and you got to make somewhat of an educated decision here. It gets you. It's a let's get close. Right?
Yeah. So we've talked about the Air Max workflows in the Trueflow app, right? This is the NCI workflows, the Air Max, but we're going to take what we're actually measuring, and we're going to take those readings, and we're going to make an air upgrade. And I think that's important to, kind of go over the difference. An air upgrade is our goal behind an air upgrade is to try to improve the fan airflow and try to get it performing the way it should and get the static pressure within range in the system. So the air upgrade is a process to improve. And that's little modifications that we could do near the equipment.
Right. So we call it surgical modifications, and that's the idea.
Dom, I like the word surgical because that's what the app is trying to help you do. The last thing you'd want is to recognize you got low airflow and high static pressure, and so you put in a bigger filter grill or bigger filter rack, only to find out the return ducts were the restriction. You sell the upgrade and you still got an airflow problem because you were aiming in the wrong spot. But the app is going to help you to figure out, should I be upgrading the return trunk and branches or the filter or the supply, or is it just a dirty evaporator coil?
Okay, so we've talked two workflows kind of linearly, right? Static pressure screening. We've talked about static pressure and using the fan table. And then there's the third one, which is when the Trueflow gets involved. And we kind of got through that. And the reason I want to go back to it and talk a little bit about it is for the forecasting feature. It's like my favorite part.
Yeah.
So
I wanted to bring that up.
Yeah,
that was number one.
Yeah.
Go ahead.
Okay, so circling back, let's talk about it. Let's just keep it linear. We're doing the third workflow now. This is the one means you've bought the Trueflow, you have our manometer, and you have our grid and our adapter plates, and you're using this for a purity flow measurement, which you've heard by now, which is what we desire you to get to.
Let's press pause. Why don't, for anyone that hasn't actually seen a Trueflow grid, can you describe what it is and how it works? Just give a very high level summary.
So the Trueflow grid is a grid with measurement holes in it, and it goes into an adapter that goes into the filter slot or the filter grill, wherever the filter is in the system. And there's workflows if a system has multiple filters. And its purpose is to measure the airflow directly, so you're not depending on the manufacturer's fan tables. You're not depending on taking a single point measurement in a duct. And it works very well even when there's an elbow going right into the filter. We've done a lot of testing and development of it to make sure that we can get an accurate flow measurement regardless of how that airflow is messed up.
And key word, I want everyone to pay very close attention to what Steve just said. He said measurement. Notice if you were paying attention earlier, we've used the term calculated and estimated airflow when talking about the two first workflows and plotting fan airflow. This is actual true measured airflow.
Yeah.
So I want to go one step deeper than even we're doing, because this comes up a lot and it gets talked about, and I want Steve to tackle it. Steve, a lot of people look at the Trueflow grid and they go, oh, well, you're just taking a traverse. Who out here has done a traverse where you've taken a pitot static, put it in the duct, right? And
Yep.
you're looking for velocity? Steve, can you tell them that while this is not a traditional traverse?
The reason it's not a traverse is because it's actually a flow conditioner and an averaging pitot array sort of in one device. And the testing that we've done was to confirm that that flow conditioning function actually works. If you look at the standards for doing a pitot traverse, typical residential system, you would really need about 12 to 14 feet of straight uninterrupted duct in a residential system. It never happens. And so that's why we need something that can condition the flow as we measure it.
So my favorite part of that, you didn't go where I was hoping you'd go, but our technology is differential pressure drop.
Yep.
That's the big squeeze for our flow measurement, while Traverse is doing more, they're focusing more on velocity,
Right.
right? And so it's not a Traverse, but it's similar.
Yeah.
Like velocity is a function of pressure drop, but it's not exactly how we're doing it. It's different. That's why we were able to take a purity flow measurement with only 6 inches upstream and 2 inches downstream of clearance from the grid, which is really a tight margin when you think about a purity flow measurement.
Yeah.
Okay, sorry, had to get that out there. I get that question all the time.
That was great.
Okay,
You want to
so
circle back to forecasting?
I do. So now that you know that we've got a purity flow measurement, okay, and we've got static pressure mapping, now we got gold in our hands. Once we do that, we've baselined the system, we've characterized it, okay? We can do anything with that at that point. Fan Law 2 comes into play, and we can just get wild. We can start designing replacement systems or surgical repairs. And we can do that with a feature, and that feature only comes after using the Trueflow grid workflow. So you're probably thinking, okay, what does that mean? That means if you have, let's say you walk into a house and there's a 3-ton system, and it's got a filter and it's got a box coil after the furnace. So you've got exterior components away from that fan motor, which we talked earlier about pressure drop and all that. Okay, let's say that the filter's very restrictive, but you have the flow you need, right? But the static dial is over an inch of static. You can do that workflow, select forecasting, make a couple design selections, and then you'll get to an active simulator screen where you could say, well, if I put a new system in and I decide to lower my filter static pressure drop to here, I want to know how far do I have to go with that to get a new system that's going to look beautiful on all my dials. And we will show you that. And we will even let you print a report out like that. So you could go to the customer with a report that is showing the problem and a report that is showing how you fix the problem.
And that might not be too difficult if you're aiming for the same airflow. You're replacing a 3-ton with a 3-ton and you were getting enough airflow. But if you're doing your homework, you probably realize, well, that 3-ton's probably oversized and it really needs maybe a 2 or a 2.5. But then the question is, okay, if I put a new filter in with the new system and I go down, I can get from a 3-ton to a 2.5 because I've done my load calc and I've done my homework. But how much is the static pressure going to come down? And that's really hard to know without doing some calculations. And if you want to break out your own spreadsheet and do fan law 2, you can, but most people aren't going to do that. So we've built that right into the app so that, like Chris said, you can take that, there's a capacity slider and say, well, what if I wanted to do a 3? Ooh, that's not going to work for this ductwork, but 2.5, I can get the airflow that I need without breaking the bank on static pressure if I can get it down to a 2.5 ton.
Yep. I wanted to mention, you said you used the word design, and I know, like when everyone's thinking about airflow and design, your forehead starts sweating, right? You're like, it's scary. How hard is this? Is it difficult?
I hate doing load calculations. I'll say it. I hate it.
That feature it might scare some people because it's difficult to do, right? How hard is it to actually use the forecasting feature?
Okay, now that's a hot topic right now with me because I am like the tech support for forecasting. And here's what I'll tell you. In my mind, it's a beautiful thing and it's super easy. And apparently it's not as easy as we could have made it, maybe. For me, I'm like, it's phenomenal, it's super easy. And I get some people who go, dude, that's the best thing since sliced bread. I love it, I use it. But I have also people who call tech support and they're like, I'm not sure I understand this. And so let's go back to training. You need training. Because the problem is forecasting too difficult, or did they go to trade school and not get taught airflow? Right? Where's the real problem? The problem is there wasn't enough training built into this technician on the airflow side, and now he's got forecasting in front of him, and he wants to be a designer based off what's installed. Which, let's be honest, that's a mountain to climb.
Right.
It's especially a mountain to climb where you have no airflow training from trade school, right? And so where do you go from there? And my opinion is you got to get some training, and then you'll look at forecasting and go, sweet. But if you try to go into forecasting with no training, you're going to be like, I don't know what I'm doing. Chris, what's the Great Triangle mean? I don't know. What do you mean existing? What does that even mean? I'm getting all these questions, and I'm basically having to explain what they took initially for measurements and bring them over to forecasting, because it's just a lot of thinking that's going on. And we've took what would take normally. Okay, before forecasting existed in this app, if I pressure profile the system and I'd go to the fan curve chart and I'd do it the old school way, at best, I'm 30 minutes thinking about it. I can use forecasting and I can crank out the same work in about a minute, right? And that doesn't sound like a lot, but if you want to walk downstairs and go have a conversation about a new piece of equipment sale with a customer, 30 minutes matters. You know what I'm saying? I want to do it fast.
So, and you mentioned training. So a lot of the basic premise on how forecasting works, NCI, we have a class that actually teaches that. If you want to learn like the backbones of the formula, and if you want to understand how to predict airflow and static pressure and that's in our duct system optimization course.
Yeah.
Yeah. So there's a presentation later today. Am I right?
Yep.
David Richardson. So if you are sitting in the stands and you're like what you're hearing, and you want to learn more about the training side of this and what an air upgrade is and what it means to NCI, you should go to David Richardson class, which is right there. Stand up, David.
Think about it.
Yeah.
So he's going to be talking about air upgrade today. Can you tell him what time that's going down?
Yeah, that is today from 4 to 5 p.m. And let me see, I have it at, I think it's I don't have it off the top of my head now. Oh, W311D, room W311D.
Yep. Okay. And so I think we should dibble-dabble a little bit in where do you go get this at? And we should also mention about these workflows being in MeasureQuick. Because I'm sure we've got some MeasureQuick users who are listening to this too.
Right. So does it work on an Android phone? Does it work?
No.
Do we need a phone? Is it a tablet? Does it work on an iPhone?
You need a smartphone. It could be any kind. Android, Apple, like our app. Our app is the Trueflow app.
It doesn't work on Windows Mobile.
So I got to get rid of my flip phone? Is that what you're saying?
That's right. So that's, you can download it at either the Google Play Store or the iOS Apple Store. Download the app. Like I said, there's no fee for it. MeasureQuick has these same NCI workflows baked into it as well. And that is the MeasureQuick app, and you can download it from the, Apple Store or the Google Store. Get it there. It's you could probably speak on it a little bit better than I can.
Same type of workflows for both. There's different looks for each, right? Different illustrations. So if you're like a MeasureQuick power user, you might prefer MeasureQuick. If you're a Trueflow guy and you don't really, you're not a MeasureQuick user, use the Trueflow app. But no monthly subscription, no download fee.
And that's a change that you guys have made to who can access the AirMax apps, right?
Yeah, AirMax was an app. This was a thing.
It actually is still an app, but we're kind of like phasing it out, so it's still available. But it's much better, obviously, on the Trueflow app because you have the ability to talk to the instruments and so forth, whereas before you had to manually punch everything in.
So I'm going to challenge both of you guys from NCI on this panel, and I'm going to say, who's the right person to come to this training?
The right person.
What kind of people are we trying to pull in here?
Well, I mean, obviously, you have technicians, and it's great if every technician had a Trueflow on their truck. That, especially just starting out, that could be pretty, difficult. They're priced well, but they're expensive tools. I would say, having that person who commissions the system, absolutely. But honestly, I also think it's a great sales tool. So the salesperson, with some training, could take that Trueflow app and go on that call, whether it's a call where someone's having trouble and that they need help, or even just a replacement call. And it takes just literally minutes to slip that grid in there.
And you mentioned sales tool, so you could use it to present options and sell to a homeowner.
Correct.
But that salesperson could also use it as a design tool to provide and install a system that's actually going to work the way it was designed, right?
And what does that salesman? Okay, I own a company right now. I don't. I'm just saying theoretically, I own a company. I don't want to go back to that. I did 20 years. I'm done. I checked out. Okay, so let's say I own a company right now, and obviously to get a technician is scarce. A good one, right? It's a difficult challenge. Everybody's talking about it. Okay, I'm going to go start plucking other resources. I might go to Xerox Corporation and headhunt. Who knows? Whatever. I get the guy to come in. He's got soft skills, and we're like, heck yeah, this guy can talk the talk. Now I'm going to build him up. How do you take that guy under your wing and build him into what we're talking about right now? What's that look like?
Well, there's a training ladder, if you will, to it. There's a class called Airflow Testing and Diagnostics, and it's a one-day, and a lot of the times this class is available online. Right now, about every other month. So that's a great stepping stone because it's going to teach them the basics, static pressure, what is it, airflow, and kind of build them up. And then they can kind of graduate to what's called duct system optimization training, which now you're getting into more of like, how do I renovate a duct system? What do I need to do? And then from there's other classes like residential system performance, where we're actually looking at delivered BTUs into the space and in each area of the space. So it really gives a path for how far do they want to go, whether it's a technician, salesperson, etc.
You want to add some more to that?
Yeah, that's like you said, it's the path to high performance, right? Chris and I just did a couple of months back. We did a training in Ohio, custom on-site, and it was kind of geared towards salesmen. There were some entry-level techs there, and there were salesmen, and we worked together, and we developed a game that would kind of allow you to visualize what needs to change in a system, right?
Yeah.
So I want to say one more thing about using the Trueflow as a sales tool, and that is, we talked about several different ways you could estimate or measure airflow, but particularly if you're in a system replacement situation, what are the odds that system that's currently installed, and maybe the blower is the only thing that works, has a clean blower wheel, has a clean evaporator coil, and has a clean secondary heat exchanger? Because if you don't know if those things are clean, then that fan chart's not any good. 20-year-old system, it might not even have the original blower motor.
Or was it even right in the beginning?
Right, exactly.
Ooh.
And so
No, we don't oversize stuff.
so
What are you
if
talking
you
about?
so if you verify the static pressure on that existing system, you really know next to nothing.
True.
And so if you can match that static pressure measurement with a known airflow, which you can do with the Trueflow in 10 minutes, then why would you bother to try and clean up that system just so you can estimate the airflow?
Yeah.
So I want to jump back. I was kind of joking there, but let's get serious for just a second. A little bit of a concern I had working for Steve with the Trueflow was like, well, we have inverter systems now, and they have the airflow reported on the thermostat, right? And you're thinking, well, we're going to be out of business. And then we put a unit on a chamber where we can measure flow down to like with 1% of inaccuracy, right? Like that's the level of the chamber gets. And Steve, stop me at any time you want, because you're the engineer, I'm the technician. But like really, really accurate. So when a unit is being tested, they put it in the most perfect situation, and then they test it. So it's like the fan curve chart works phenomenal in that situation. But that's not the situation the equipment lives in. The equipment lives in the field, where it changes every time you install it. And so how accurate is the fan curve chart in the field? And, if you have the most beautifully installed system, and, I mean, of course we always have builders who say, how much room you want?
Yeah.
That doesn't happen.
That's a good point. I've never seen in an installation manual, they don't tell you where to measure static pressure or where to measure total external static pressure. So where are they measuring to develop that fan table, right?
And I'm not trying to like beat them up, but in their defense, if they did, and all of these duct systems are radically installed, could you imagine what their tech support line would be like? It would be bonkers, and they would be like, "Take those ports out. We can't deal with this." I'm speculating here, but I think it would be a nightmare of phone calls, and so they probably had to say, "Is the juice worth the squeeze?" And I think it was calculated. I don't think they didn't think about it. I think they thought about it really hard and said, we may create more confusion if we do that.
Yeah.
So do we want to do a quick wrap-up? I think we
Yeah,
have a few
closing
minutes.
thoughts.
Yeah. Chris?
Okay, so I guess my wrap-up is we didn't finish off the statement was we put that calculated airflow from the thermostat, the digital readout, up against the chamber, up against the Trueflow, and we found is it's not always accurate. So we know we're not going out of business.
Yeah.
All right. So that's all I got to say.
And that was with a clean, brand new system.
Yeah.
Yeah.
All right. Steve?
So thanks for having us on, and I hope we can make it easier to get air upgrades done. Get the tools, get the training, learn how to do it, and you can solve a lot of problems.
Awesome.
You can become the HVAC expert in your community who's call that guy if you got a problem system. Comfort problems? Yeah, I don't want to deal with that. Call that guy.
I just want to share some thoughts about something. Going back over the years with NCI and looking at tools in our industry come and go. And there were some good ones and there were some not so good ones. And some of the tools that we looked at were testing instruments, if you will. The folks, and most of these are out of business now, so I can say this. But the idea was, this is so good, even a trained monkey can do it. That's how great the tool is. Well, I can tell you right now, that just is not true. And one of the things that attracted us to TEC is they don't believe that. They're like, you need the knowledge, you need the training, you need to be able to discern your readings. And like, what am I really looking at here? Yes, the tool is giving me great information. And what I believe is we've gotten to the point where if you're in the field, the tool, the Trueflow Grid and other tools give you more time to think about what's there. Because you're not worried about, did I do the math right? Did I do this right? So it opens you up to like have vision about what's going on with that system. And I think that's so important. Oftentimes we miss that. And there's still a few people in the industry that feel like, well, we should make it so that a trained monkey could do it. I just don't believe that. I think you guys out there, your technicians, you're extremely valuable. Just continue to build your knowledge and your ability to think, to really think about what you're looking at. And so that's my words of advice, if you will.
Awesome. Thank you.
Yeah.
So once again, I am Adam Mufich, and I'm with National Comfort Institute with Dom Guarino, Steve Rogers, and Christopher Hughes from the Energy Conservatory. And we're going to sign off from AHR 2025 in Orlando, Florida.
Woo!
Thank you.
All right.
Thank
Thanks.
you.